Hello, everybody. Welcome back to the Engine Nerds Team 9892 Coding Bootcamp for FTC. Today, we're going to be going over servos, which are very similar to motors, but instead of a set power, you're going to be doing a set position. But we're just going to be explaining all that throughout coding it together. So, again, we're going to go to external samples in the FTC robot controller. And we're going to copy a file and bring it down to the FTC team code. I'm gonna call it servo example. You can call it whatever you want. Just make sure that the file name is um, in the public class. So, and I just Control A delete, get rid of all the code so we can start fresh. And now what we're going to do is we're going to add the package org.firstinspire.ftc.teamcode. And I also need to add our import statement. So import. And then I'm going to do our first one, which is the linear op mode. So com.robotcore.eventloop.opmode.linear op mode. And I also need to add a autonomous one. And while technically I can add our teleop, this is all going to be done autonomously. So again, I prefer to keep it our autonomouses with our autonomouses and our teleops / driver controls with our driver control stuff. And also something else we need to add is our servos. We do need to add those. So again, it's just robotcore.hardware.servo instead of event loop op mode and then whatever. And then now what we're going to do is we're going to do add autonomous parentheses name equals quotes, and I'm going to call it servo test or servo example. And then I'm going to do underneath it public class servo example extends linear op mode. Nope, not line, but linear op mode. Okay. And then I'm going to do curly brackets, and now I'm going to add our at override, and then public void run op mode. Parentheses, curly brackets. All right. So now we have that. We can add our servo variable names. And the way you you create a servo variable is you type in servo with capital S, and then whatever your servo name is. I'm going to call mine servo FL for front left, and I'm going to call it servo FR for front right. Again, I'm only using 2 servos for this example. You can use as many as you would like. Again, this is kind of just explaining how servos work. So now we have this. We also, very similar to the motors, have to create a hardware map. So again, all we're going to do is we're going to come down here, and we're going to do servo FL equals hardware map dot servo dot get, and then in parentheses or in quotation marks, you're going to type in whatever you want. You're going to call your servo in the robot controller app. And again, I just call mine for servo FR or FL for simplicity, but you could do whatever name you wish. Now I'm going to do servo FR equals hardware map dot servo dot get quotation marks servo FR, and then semicolon. And one thing that you'll note is different about the servo hardware map and the motor hardware map is in the motor hardware map, you just do hardware map dot get and then you DC motor class. In this one, all we're doing is hardware map dot servo, which is technically the class, dot get, and then servo in your servo name. In this one, we have to do hardware map dot get and then DC motor dot class, which is a difference, and it's just one to note. Something else we're going to have to do is we're going to do servo.setDirection. So I'm going to set the front left one to reverse. You can do either one. You can do both. But again, for this example, I'm just only going to set one to reverse and one forward. So reverse. So again, I have my front, or I guess, yeah, we'll do front right for reverse. So we did servo.fr.setDirection, servo.direction.reverse. And then for the front left servo, we're going to do set direction dot servo direction dot reverse. Or I'm going to do this one as forward, so we have two opposite, like two servos going the same way. And what I'm going to do is I'm going to set the position. So servo fl dot set position to 0. And I'm also going to do the same for fr, and I'm going to set the position to 0. Again, this is mainly just so it doesn't move upon initialization, because now we're going to add the wait for start. And the wait for start basically means that, hey, all this stuff is the initialization phase. After this is going to be the driver control phase, or not the driver control, but the autonomous phase. So now what we're going to do is we're going to do servo fl dot set position. And I'm going to do 0.5. You don't have to, but I'm going to. And servo fr dot set position 0.5. And very similar to the motors, what we're also going to have to do for this code is we're going to have to add a sleep command. And I'm going to set this for 1 second like we did in the other example. And then, because as of right now, our code is just saying sit at position 0.5 for forever. I want this to close, and I'm going to set the position back to 0. So again, servo, I'm going to copy and paste the one up here, servo fr, set position 0, and I'm just going to put it down here. And voila, you have a code that basically says, hey, open and close my clause. One thing to note, if you are using continuous servos, the servo position for 0 is 0.5. So this variable right here would be not moving the servos at all. But on regular servos, 0.5 is an actual position it will rotate to, which is something to keep in mind. 5-turn servos, I don't know enough about to comment on this video, but if you would like to do further research on your own, feel free to, and possibly let me know or let the mentor know on how they work. But with that, this concludes this video. I really hope this was useful and you guys enjoyed it. But yeah, we'll see you in the next one. All right, bye-bye.